Thank you, Wolfgang. But what I think we should do, I've been asked by a client to align like two models together. So if we've got enough time, we'll just do that as well. It's not related to the vertex split, but I thought that, you know, if we can record it, I can give this information out without making another video. So we just throw it all into one lump thing. Okay, so I hope that's okay. So let's just share this screen. Okay, do you see my screen?
Yeah, by the way, I do like your background. Looks really good.
It's got a lot of blue in it, but I enjoy working with blue. I don't know, that's just me. Okay, so here's the models that we always use. And the first thing we're going to do is we're going to align it to the center of the workspace. Wolf, can you just elaborate quickly why we align this thing to the center?
Yeah, so when we make model bases, imagine the model bases, they are made or extruded, we call it, into the vertical direction. So if you had your models sitting at an angle, the model bases will go skew, and we want to try and eliminate that. So that's really the starting point, and the scans need to face us, not backwards or sideways or anything like that. So the first part of the model designer tutorials specifically teaches that. And also later in the crown and bridgework module, we've got to, it's not a luxury, it's more of a necessity. We have to do this. So just getting it in the center, please. That's very important.
Okay, so that's what I'm going to do. We're going to just name this and flip it upside down. The lower antagonist is hidden away. So this is all part of the model designer. So we're not going to explain this in great detail. So we're going to align that. And so this is sort of in the center of Blender now, as we can see. And then we're going to extrude them into bases. So here I'm going to select the upper and make an upper base. And then the lower, make that into a lower base. Good. Now I've got quite a few modules on my side here, so I'm going to have to actually look at what I'm trying to get. So I'm going to go to the vertex split. The first thing we're going to do is we're going to select both of these models. So this one and that one. So they're both highlighted, and we're going to move them into a collection. This will put them into a vertex models collection, and also they are joined up. So we all know that in Blender we can join up models and we can separate models. So in this case, these are joined up into one model. Then what we're going to do is we're going to go to the components module. And there we're going to load our library, and we're going to look for the vertex split. So Wolfgang, can you just quickly explain with the vertex split how that actually works?
Yeah, so the first part is the blue component, and that's the insert. So basically this component, once it's printed, the serrated lower part will slot or snap into the cavity of the plastic injection mold. So these are available through the Blenderfordental shop, and we sell them currently in packs of 20. Now, the good thing about the system is they are reusable, and it doesn't really matter what patient case you're going to mount on this insert. It's irrelevant. They will all fit into this base. So this is a big plus for us. There are many other plaster systems that I've been working with. It's really a one-time use only. So this is a multiple use item. So Michael will import this insert into the scene, and then he will show how we're going to connect these dental models, basically unify them onto this digital insert.
Yeah, excellent. So as you see, we've appended this to the center of Blender. And now what we need to do is we need to line them. But because we've got two models, we need two inserts and we need to position them correctly. So what I'm going to do is I'm going to select it. It is highlighted. We're going to go back to the vertex split. And then what we're going to do is we're going to go to next menu item where it says place selected lower insert. And that puts it to the lower and we can see it in the front. Now there's a reason why it's positioned exactly where it is. Wolfgang, can you just elaborate on that?
Yeah, so this one is positioned below the horizontal axis, and you can see the red line. Now, in future, we're going to have an articulator mounting plate, which will be used so the model base will fit into the articulator mounting plate with a magnet. So having this at a set location for the lower, and when Michael duplicates it for the upper, we will then be able to mount this in an articulator and keep these model bases on this very same articulator. So again, no matter what patient you're working with, you can just slot these dies. The aim here, the goal is we only want to print the dies. So we're taking the many variables out of the equation. By printing large models, we've got more chances of misprints. The surface area for dies is very small, and we get really good results just by printing the dies.
Excellent. So what we're going to do is we're going to copy the selected insert to the upper side. So this would then be in an articulator, but because we're not doing this in an articulator now, we may want to reposition them so that the dies are not too long. So what I'm going to do is I'm going to select that and unlock this, which means I can set this up and down. I'm going to set this to, I don't want the actual dies to be too long. So we're going to set it to there. I'm going to click here and unlock that. So this is lock and that's unlock. So let's just, having a look at my die, my front die. And as I'm moving it, I don't want it too short and I don't want it too long because we want it sort of, would it be like a third maybe?
Yeah, I think so. We look maybe from, probably from the gingival margin, we'd look at 6 to 7 millimeters until you get to the start of the insert.
Something like that, I would think. Okay, so we're looking at from the front view. You can look at it from the side view, but we see the models aren't exactly where we want them. This is where we're going to head down the next step. We're going to go align models from the top view. So this puts us into transparent mode, similar to the study models. We've got very similar procedure. So here using the G key, we can see where the cavity is. This is where the cavity is. I'm going to place this now into where the cavity is, more or less, okay? So, because we want the teeth to be above the cavity, so we're not going to place it there or there or there. So we're going to sort of estimate something like that.
Yes, so Michael, just stop there. Here we can see the overlap from the top view again. Never mind, you could actually see which part would be trimmed away by importing special cutting tools that we have.
Yeah.
And Mike will show this in a minute. And this will also largely determine what cutting tool you need to use. For this one, we would probably use a medium-sized one, and that's got the walls of the cutting tool extend slightly upwards and not too high so we don't cut the teeth.
So Wolfgang, essentially we want to get rid of this because this is disturbing our insert, isn't it?
Yes, that's correct. Now, instead of doing it manually using lasso cutting tools and various cutting tools to trim down the model. We have created cutting tools that will do this job for you very quickly.
So these are the cutting tools. Can you just sort of explain to us? You know,
Yes,
here I can see one very shallow, and this one is, yeah.
So the first one, which is very shallow, and we call it short fit trimmer. This is really designed for dental models which will actually fit on the base. So you don't see a lot of overlap, if any. There should be no overlap. So the next one would be a medium fit, and you can see the walls of the cutting tool extend slightly upwards. This will trim away any overlap. And then the next one, the long fit, will actually trim fit higher up. So all of these are designed to trim down the models so that they fit on the actual insert. The next one, there's an ergonomic one that's got an opening in front. We know that sometimes anterior teeth can kind of lean forward. So that gives you additional room to bring your models further forward.
So Wolfgang, that's like when you have like buck teeth and they're standing like really forward, isn't it?
That's correct. And then it's got heels at the back. Just hold on, I'll just mute that. So we've got heels at the back to trim it off. The other ones that are marked overlap. Now, we've been asked, or the questions come up with, but what if the models are larger than what the insert is? So, of course, the solution might be to have another different kind of a plastic injection molded insert, which is slightly larger. But the other solution is to create cutting tools where the model bases will slightly overlap the plastic injection molded part. So the serrated insert will still slot into the cavity, yet some of the model will extend slightly over. So that will give you the ability to use larger tooth arches.
Excellent. So Wolfgang, which one do you think we should use for this one?
Just
the shallow one?
No, use the medium trim, because we could see from the top, we could see a little bit of overlap, and that will get rid of that.
All right, so we've got one, but we need two of these. So the menu does exactly that. So I'm going to select that, and we're going to duplicate selected. We call them model trimmers, because, you know, labs like trimming models. No, they actually don't. But so these are like the quick digital model trimmers. Now, these are not in the correct position because you can see this is duplicated.
Yeah,
so what we're going to do...
Just stop there, Michael. So yeah, I mean, it's just imported it in a random position. Remember, we've changed the location for the insert. So it would be a very difficult task to try and align these trimmers to the actual location of the insert. So this is where the trick comes in. We're going to use a snap feature in Blender where you can select the trimmer and snap it to the exact location of the insert. This is the beauty of it.
It's like magic. So I'm going to take this one and snap it to the upper insert. And I'm going to take, so what it's done, it's flipped it 180 degrees and it's put exactly where we need it. And I'm going to take this one and snap it to the lower one. So now they're in wireframe. Why did we put them, why did we make them in wireframe?
Well, you can see, you can kind of visualize that cup shape cutting tool, because I mean, at this stage, you can still select both models and you can still pull them either way. And if you look at it from the top, Michael, or just angle it slightly so you can see the anterior position of the insert, just rotate it slightly so you can see the lower anteriors, and you can see there's a bit of space there. Yeah, you can see a bit of space exists there. So one can still move those teeth back and forward and slightly sideways if you want.
So we can just move these teeth if we want to. We can just move them if we want to.
Yeah, just the teeth. Yeah. So select the teeth. Yeah. So then by using the arrows, you can still do small minor changes. Of course, it's a lot easier when you're only working with one model, because now we're using two models, and we want to keep the inserts unilaterally or symmetrical, mirror image, because when we mount them on an articulator, you can imagine we don't want one insert shifted slightly to the left or to the right. So it's got to be exactly mirror image to each other.
So Wolfgang, assuming we want to have a different cutter, we can just delete this one and bring in a new cutter if we want to.
And then snap it back to the insert. That's correct.
So shall I do that now, or shall we just continue?
I think it's okay. This is sufficient. It will cut it quite nicely, Michael.
Okay, we're going to go trim around models, and that should then trim the models, which it's done perfectly. And then we're going to click on Unify to
just
Models.
Just stop before you do that. Sorry to interrupt.
I have already.
Okay. No, that's all right. You can actually go into edit mode and look at the mesh geometry, and you'll be able to see where the cutting tool is. There's various different mesh geometries here, but either way, we've tried to keep the mesh geometry as simple as possible. This is because we want to use the Vertex cutting tool after that to section these dies. And you can imagine if we've got a very complicated mesh, your computer's going to go in thinking mode for a long time. And sometimes these Boolean cuts can actually fail. So by having a very simple mesh geometry, we're safe to say that the Vertex, the splitting of these models is going to be successful.
So the next step, of course, would be to view it from the bottom. So we're going to view it from the bottom up. So that's the top, that's the bottom. And then we're going to use a vertex cutter. So I'm going to shift right click, and we're going to go into the model designer, and we're going to select the cutting tools, and we're going to select a vertex cutting tool. Now we do suggest using the vertex cutting tool because, again, it's not a complicated cutter. If you're using the lasso cutter, you can do it. But remember, the more vertices you have, the longer you're going to wait. Okay, that's just the general rule. So here we've got one vertex, and I'm going to extrude it. I'll first use a G key and then the E to extrude, and we can go all the way through there. Okay. Then I'm going to use a Shift D. So this is where you need to know the Blender shortcuts. Okay, so Shift D is to duplicate, Shift D, and then E to extrude. We're going to go Shift D and then E to extrude. So this is how we're going to continue. Shift D and then E to extrude. I may go corners like this. Okay. Again, Shift D and E to extrude. So this is the general pattern that we do. So I'll only go up to there, or actually, yeah, I'll just leave it at that, and we're going to cut it now because we're focusing on the. Actually, let's just do all of them, Wolfgang. What do you think?
If you want.
So Shift D, E to extrude, Shift D, and E to extrude. Okay, so here it's a bit of a tight squeeze, like that. Okay, the next thing is we're going to click on Slice. So we're not going to click on Keep Outside or Keep Inside because we want to actually create a slice, like a disk. Okay, so when I zoom into this disk, it's separated. Now, this is 0.1 millimeter. That's 100 microns in thickness. Wolf, can you explain what the suitable thickness should be, do you think?
Yeah, so this all depends on your burn layer. So our novel idea in this system is we're using the burn layer as part of the clipping mechanism. Now, the burn layer doesn't discriminate against which sides it's going to go. It's going to go all the way around the bottom of the die, not just buccal and palatal. So the burn layer underneath will extend mesially and distally. And you can imagine if we're going to make a cut of 100 microns, those burn layers are going to like interfere with each other. You can forget about fitting the die. So the way to do this is, yes, you can make 100 micron cuts, which is very fine, but then you need to sand down just the mesial and distal. And that just means a swipe over some sandpaper of the die so that you can actually, they will just slot in next to each other. Alternatively, by setting that gap a little bit bigger, you hopefully will avoid that burn layer collision with, with each other. So this is just something to be mindful of. And Michael will show it once he's trimmed it down. So I've used 0.2, yet I still like to just give it a quick sand down or just take a burr.
So shall I put it to 0.2?
Yeah, I mean 0.2 is very small. It looks massive digitally, but once you've printed these dies, it's actually very small.
I know, it's like looking through a microscope, isn't it?
Yeah.
And then we're gonna accept that. And then that'll then split them all up into sections. As you can see, it's like playing a piano. Ding, 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 ding. Okay, I'm not good at that. Okay, but anyway, so let's just talk about the burn layer. I'm going to Control I to select the inverse and hide it. So here, the way you've designed that, Wolfgang, was actually quite clever because you've got this little chamfer here, okay, over here.
Yeah.
And this is what you're talking about, because the burn layer now would be coming something like this. Am I correct?
Yeah, it will bulge out. Now, the start of the angle to the bottom of the angle is 0.8 millimeters, okay? That means we're going to set our burn layer. Generally, we set our burn layer at a longer time. Maybe if you're printing 100 microns, you might do 8 in this case, or just work it out. But we've got 0.8 millimeter gap for your burn layer. So whatever you want to set, it doesn't really matter. So to complement that, we still have incorporated a little bit of a step higher up, just to make sure we get a correct clipping mechanism happening. So Michael's drawing the burn layer as it would happen on the mesial or the distal sides. And of course, you can imagine if we leave it and the slice is too narrow, they will collide. So you can just trim it off. It takes like less than 10 seconds. And then just to ensure each die will slot in into the injection molded base.
Well, that's true, because if that slice was too thin, this will collide with the other side, isn't it?
Yeah.
Because the other side is coming like that.
Exactly, Michael.
Correct. So that's actually quite clever. And I mean, the clicking noise that you've shown in the video is quite evident how well these things fit, because you just take it off your printer and you just slot it in, isn't it?
That's right. But the other thing is, please, you guys need to make sure your printers are calibrated correctly. I don't know, I've printed hundreds and hundreds of dies with you've got to just take a calibration cube. If it's correct, then, you know, these things will slot in very nicely.
So of course, the next thing would be to ditch it, isn't it?
Yes.
So shall we just ditch one?
Yes.
Just to demonstrate. So we're going to draw the margin and we're going to extrude around the margin. Okay, we don't see much of a margin on this one, as we know. So let's just
ditching is done at the very end. If you ditch first, then you will have dies that have got bits of gum hanging up in undercutting and things like that. So we want to prevent that. So do the ditching towards the end.
So in Blender 2.93, in the latest module, we have this. Before we needed to go Alt left click to select the edge loop. Now what we can just do, scale the top, and then it selects it automatically, and we're going to scale it and scale the bottom as well, and S to scale it out. Now that looks like quite a nice ditch to me.
Michael, can you just show that edge loop, you can pull it up and down and rotate it still? Sometimes that comes in quite useful.
Like this, you're talking about this?
Yes, or you can GZ.
We can move it down if we want to.
Yes.
Yeah, so there's quite a lot we can do. Also, I've been pointed in the direction that the 2.93, if your die is undercut, I just like to mention that this edge loop here, we need to be very careful and always check that if this die comes out like this and is undercut, that loop is going to cut into the die. So most of the time that never happens because we don't have, you know, mushroom looking dies. We should never have those. But if that's ever the case, just check so that you can always go with the Alt left click, and you can always scale this one out a little bit, and that's very easy done. Okay, but other than that, it looks like a perfect ditch, and then we're going to just apply the ditch. Perfect. Okay. So so that sort of concludes that. And while we were doing that,
we've been asked if you can hollow these dies as well. Of course,
okay.
I don't really do that, but you can. And the reason I don't like doing that is because when you get the dies hollow like that, and Michael will show you, and you've got to be super careful that you don't break them when you're taking them off the build plate. When they're solid, they've got a bit more strength, but when they're hollow, then, but you can try it out if you want.
Would you then do hollow or honeycomb or something? Just
yeah,
I'll just do hollow or something.
Maybe hollow. But actually you should hollow first, and then you should actually hollow first, Michael. But the hollowing is done first, and then the cutting of the dies, and that is because otherwise you're going to end up with dies that are sealed but yet hollow. So,
but if you do hollow, I'm doing the lower model now.
Okay. Yes.
So just to demonstrate, so if you would hollow, you would actually move this cutting tool out and away from this whole thing.
Okay.
Because you can see it's been hollowed on the inside. You don't want to cut anything off.
That's right.
So this is why this tool is so handy to have, because we can just move it out of the way.
Okay, so then cut it and then see if you can make a die out of that. That'll give a good demo how that actually works.
Okay, so Control I and hide the rest of it. And we're just going to look at it from the top view. Then Shift right click to place the cursor. We go to the vertex cutting, use the G key, and then the E to extrude, and then Shift D, and then again E key to extrude. Okay, so let's make a slice. So make a slice. I'm going to set that to 0.2, and we're going to accept that. Okay, so basically you're saying that's what it would then, theoretically look like. But you said that's quite fragile, didn't you?
Yeah, so maybe putting a honeycomb, that I'm not sure how that's going to look, by the way, but I think it would look quite awesome. Or, Michael, maybe you can even use a gyroid, but I'm not sure.
Well, I can give it a try.
Just give it a go.
Let's give it a go and see what happens. I'll just go back a few steps. Okay, so that, Control I and hide. So let's hollow this, make hollow, and a gyroid.
Yeah, who knows?
Yeah. Okay, let's have a look and see what happens. I've never done this before, but As we know, the gyroid may take a little bit longer to do. We're going to pull this all the way out, and then we're going to accept, apply. Okay, so that'll be quite interesting. View this from the top. Okay, shift right click, and we're going to grab our vertex. So G to grab, E to extrude, shift D, E to extrude, make a slice, 0.2, and accept that. Okay, so that's quite a, that should look like a tricky geometry, I think. Oh wow.
Wow,
Oh wow.
that's radical. That
We've got
looks
it, we've got
pretty.
it,
That
we've
looks
got a few.
unusual. Mm.
Wow, that's like, that looks like trabecular bone, isn't it? And then you've got the cortical bone on the outside.
Yeah,
That's impressive. I like that. That's just
biomimetics.
super, super amazing. Super amazing. We should print one. Excellent. Okay.
Yeah, that's
So if
pretty
there's any,
cool.
I think if there's any questions, we can, because
Yeah,
that
by
sort of
the
sums
way,
it up.
when is the background theme available? Because it's quite nice. I'm quite keen to use it.
Yeah, I'm still testing it. So I want to get this thing really nice. So there's still a few things that I've got to change. Yeah. So I think that sort of explains the vertex. Shall we just engage in the author quickly?
Yeah, just go for
Well,
the author. Then we can just